your class that I do first period because I get lazy about third period, so I try to write leader. Now, for those of you who like the title, all right, ready. Been so good last week. Bowers told me you were terrible about headphones. You just done such a marvelous job in my class. I've not had to yell at you, and I don't know when about headphones. So today, you don't mind. Now, but for those of you who like titles, title is bonding. Okay, we're pretty much done with the periodic table. And we're going to switch to bonding for probably about the next 5 days. And then we'll take a big test on the 2 units together. Okay? So, hard to say. End of next week is the earliest. I can't say that for certain. We could possibly do the earliest next week because tomorrow we're doing labs. So we possibly finish what we don't get to today. Tomorrow at the end of class. The lab will take the whole class period. Of next week? No. I will need most of the next week to teach bonding. There are multiple topics that have to be taught. Friday would be the absolute earliest, but honestly, it could probably be Monday or Tuesday the following week, which would be it right before Thanksgiving. It will be before Thanksgiving. Yes, it will be before Thanksgiving break, but it could be the Monday or the Tuesday before Thanksgiving break. If we come back the full week, then we have a short Monday, Tuesday week. Huh? 23rd? 22nd, there you go, thank you. I knew it was somewhere around in there. Right? Yeah, but we are out, we're here all next week for a full 5 days. And then we have the 2-day week, and then it's Thanksgiving. Right? Now, a bond, okay, is a link between atoms that results from the attraction for their nuclei or electrons. Now, when I say that, we're talking about, okay, so let's just say, and I remember the walls on art teacher. All right, so, all right, this nuclei is attracting this electron. All right, and this nuclei here is attracting this electron. Okay, so when I'm saying nuclei are attracting electrons, I'm not saying that this nuclei is attracting its own electrons. I'm talking about the nuclei is attracting the electrons in another atom. Does everybody understand that? Does that make sense? Okay, it's not attracting its own electrons. It's attracting electrons in another atom. So if I'm the nuclei of this atom, I'm attracting the electrons that Brandon has, and Brandon's the nuclei, he's attracting the electrons that I have. So my nuclei wants his electrons, and his nuclei wants my electrons. And that's how we're able to bond. I'm not attracting my own electrons, otherwise I'd never form a bond with anybody. Okay? Now, you might remember, if you had a good experience in middle school, some of the 3 types of bonds, or maybe you talked about it in our science. Sometimes your biology teacher will talk about maybe 2 types of the bonds and talk about ionic and covalent. Metallic is usually the one that gets the raw end of the deal and is usually not covered in another science class. That's usually the one that most people have not heard about. But ionic, metallic, and covalent are the 3 that we're going to learn about over the course of the next week. Okay? And we're going to do various things with them. Covalent is the one we're really going to spend the most time with over the next couple days. Everybody caught up? No, I said you could have, depending on your teacher. Some people will teach it, some people won't. It just sort of depends. I don't know. Depends. Okay? Some people will do it, some people won't. It's technically not part of the curriculum. Okay? But like I do when I teach honors, I teach beyond what I'm supposed to teach. Well, I said some people will. All right, so we're going to talk about ionic. This here is new. We've not talked about this. All right, this is the definition of an ionic bond. An ionic bond is a bond where electrons are lost or gained. Sometimes books will say transferred electrons. Okay? Sometimes we'll say transferred electrons when we say this. So, means the same thing. If I have electrons and I give mine to Brandon, I transferred them. I lost them, he gained them. That's an ionic bond. Now, the part that says how to determine them, we did way back about the third week of the semester. How did we figure out if something was an ionic bond? That's review. We've already done that. How do we figure out if something was ionic? You weren't here. They were. We used the periodic table. That's it, which is what I have in orange. So anything that was a metal and a non was orange, but I put it up there. All right. Anything that's a metal and a non-metal is an ionic bond.
I remember that.
Yeah, it's on the board, but you know, I figured you were trying not to look up there and cheat or something.
No.
All right. So, what groups on the periodic table love to make ionic bonds? Now that we know about the periodic table, what groups love to make ionic bonds? Okay. Now that we know about the periodic table, y'all looking at the periodic table? What groups do you think love to make some ionic compounds? Okay, people. This alpaca farm is looking really good to me at the moment. Okay. Who on the periodic table do you think really likes to lose their electrons? Who do you think really likes to gain some electrons? 14 does not really like to lose and gain. Okay, you were almost there. There we go. All right, group 1 and group 17 love to make some ionic compounds. Because group 1 wants to give them away, and group 17 wants to gain them. They were the what on the periodic tables again? They were the most right. Okay. I also gave them another name. Because one wants to give it away to everybody, and this one wants to take it from everybody. That's what they make on compound. Okay. Now, who else do you think would make really great ionic compounds besides group 1 and group 17? 2 and 16. Now, why didn't I get real excited when somebody said group 18? And are they ever going to form a compound?
No.
No. Now, do the transition metals form compounds? Of course they do. Okay? They lose electrons too. But do they do it as easily and as often? Of course not. Okay? But these love to form compounds. Matter of fact, they form compounds called salts. So we're going to talk about this later, but salts are ionic compounds. That is an example of a salt. It just happens to be the most common salt, so we call it salt, okay? But any ionic compound can be a salt, okay? So if I wrote, for example, MgCl2, that's an ionic compound, and it is a salt, okay? Is what? Why would we say water is so basic? Well, that's not enough. That's correct. We're going to talk about that in a moment. Okay? But MgCl would be a metal and a non-metal. Now, I didn't strictly pick some of this group 1 and group 17 and group 2 and group 16, but I picked group 1 and group 16. All right? CMPD is compound. Yeah. You don't want to laugh really loud like Tasha? All right? So, a covalent bond is one in which the electrons are shared. Okay? This is going to be huge on Monday. Okay? Monday, we're going to learn to draw Lewis structure. It's like dot diagrams on steroids. Good. Okay? We're going to draw Lewis structure. Lewis structures are like dot diagrams on steroids. We'll talk about single bonds, double bonds, and triple bonds. And then on Tuesday, we're going to learn how to tell their geometry and whether they're polar or non-polar molecules. Okay? Monday and Tuesday are not great days to be out, by the way. Why? Tuesday's a better day to be out than Monday. It's okay. Watch the video. You'll be fine. All right? Now, how do we decide if it's a covalent bond? We already did way back about the third week of school again. So how do we decide if something is covalent? They're all non-metal. So if we use Sheena's example from just a minute ago, she said, what example did you use again? She gave us water, H2O. So what do we know about H? It's a non-metal. And what do we know about water? Currently not. It's a non-metal. Because this was in group 1, but it's our exception. That was in group 16, so we knew it was covalent. Now, based on what we know about the periodic table, what groups do you think love to form some covalent compounds here? All right, so what groups love to form compounds again? Now that I'm doing fine on Brandon. Group 17 or what else? 16? Okay, and even, okay. So group 14 to group 17 love to form some covalent compounds. Question. Everybody there? Ah. You could use anything. How about CO2 if you didn't biology class? Or how about sucrose? It's glucose. It's sucrose. I was thinking B12. So what now? I said sucrose, but I wrote glucose because I was thinking B12. We used MgCl2, but we could put something like NaCl. You could put something like CuF2. Okay, any of those would be on it because they're all metals and non-metals. You just have to have a metal and non-metal. Be honest. Okay, and for the covalent, we put all non-metal. C and O are both non-metal. C, H, and O are all non-metal. Everybody go with those? Okay, no? Want me to wait? You sure? Okay. Now, metallic bond. This is the one that usually gets cheated and gets very little attention, and it won't get a whole lot of attention in here because it's not a huge part of our curriculum either. Okay? Now, in metallic bonds, an electron is donated to a region in space. And I will draw this when we talk about properties and how these three bonds are different. But essentially, imagine that in a metal, the electrons are not in a fixed position. They're not locked into place. They're able to move. Sort of like sand in the ocean. The sand stay in one place in the ocean. No. Okay? All of y'all have been to the beach. So if you swim in the ocean, the sand gets wet. Yep, it gets everywhere. When you take your swimsuit off when you go back to the hotel, the house, the condo, the whatever, and you take off that swimsuit, you got sand everywhere, right? Okay? Metals are the same way. When you look at the inside of a metal, the electrons are not stuck in one place. The electrons can move throughout the metal. So, since the electrons can move throughout the metal, we call it the electron speed model. Sort of like a big sea of electrons. Sort of like the sand in the ocean. There's lots of them, and they can go wherever it is they want to go. You get what now? Okay. Now, the hard part for people to understand about metallic bonding is they think, oh, welcome, is they think that a metallic bond has to have multiple things bonded to it. But it doesn't. How many of y'all have aluminum foil at home in the cabinet or the drawer? I do. Got 2 rolls of them somewhere in the house. All right? So, we write aluminum this way. Is aluminum diatomic? Y'all better know the answer to that question. Is aluminum one of our 7 diatomics? No. So are we putting a subscript there? No. It's not going to have any kind of number on it. Okay? Do we write ALAL? No. So when we write the formula, we just write Al. That's aluminum. That's the metallic bond for aluminum. Okay? When we wrote iron metal, when we wrote a balanced equation, how do we show iron metal? Alexis, if you're out there, just come in and sit down. All right? We wrote iron metal by writing Fe, right? We just wrote Fe. We didn't put anything on it. We just put iron. So if it's a metallic bond, it doesn't necessarily have to have something else on the Fe. Okay? Now, if you had something like bronze, which would be a combination of metals, all right, that's an alloy. Okay? Now, bronze doesn't necessarily have a formula that we're going to write down and you're going to have to know. We just generally write the word bronze. Or we write stainless steel. Everybody got it? Now, I want to practice this because we're going to do this 2 ways. Okay? I want you to find the type of bond for all of these using the periodic table, because we're going to learn another way tomorrow. I can't remember if either one of these or 2 of these has a mistake. Okay? And so we're going to talk about how you can figure it out and do it a different way to do it correctly. But use your periodic table to find the types of bonds. Like, here is a practice sheet. If you would like to do it, I will not be grading it. But you have a quiz tomorrow on periodic friends. So you need to be prepared to do that tomorrow. You have missed roughly 25 minutes of notes. You need to watch on YouTube to be caught up with. But it's very short. It will not take you more than 25 minutes to catch up. And then you and Andy, of course, need to make it the last. No, and the opening, but you know that.